Welcome to the high-content screening tutorial of the Cell Imaging Facility Core at the Cross Cancer Institute. This tutorial provides you with the instructions for basic use of the HCS. The images for HCS are located in the CATS building and you need to request access rights for the room. Contact Dr. Sun about it. Start the system by following steps 1 to 4. After logging into the computer with the facility credentials as usual, start the Microscope software. Log into the software with the same credentials and click OK. Under the Screening tab, select Acquisition Setup and wait for it to load. Click on Eject Plate and place your plate in the imager. The A1 well of your 96 well plate should go in the top right corner, which we labeled with an A1 sticker as a reminder. Clicking Load Plate in the software will close the imager. We'll now choose the wells you want to image. To select or deselect all wells at once, just click the top left corner of the plate layout. In the Plate Acquisition Setup window, you'll see an overview of the plate. Left-clicking a well will turn it on or off. Right-clicking will move the stage to that well. Next, go to the Run tab. In the field labeled Folder Name, type your name. For plate name, enter something short and simple that represents your experiment. Add full details in the description field instead of to the plate name. Leave the storage location just as it is, and move on to the Configuration tab. Let's start with the objective and camera settings. Choose the objective you want to use. Leave the camera binning as is. And then, select the acquisition mode, either wide field or confocal. Now, choose the plate type. Most of the time, you'll be using a 96 well grainer plate that we've provided. If you're using a different one, we'll adjust any special settings if needed. Next, under the Sites to Visit subtab, pick your imaging pattern. You can go with a single site per well, or a fixed number of sites. If you go with the fixed option, you can define how many rows and columns of images to take, and how far apart they'll be. Spacing is important as you want to avoid overexposing cells at the edges. A good rule of thumb is to set spacing to about 30% of the image size. Let's continue in the Acquisition tab. Start by checking that both autofocus methods are selected. You can also enable options like Z-series or time series if your experiment requires them. If those are turned off, the system will default to basic 2D imaging. If we've already profiled your plate, you probably don't need to change the autofocus settings. But it never hurts to double-check. For laser-based focusing, make sure it's set to focus on the well bottom. Image-based focus settings are consistent across plate types, so usually no changes are needed there either. In the third section, site autofocus should always be set to all sites. If it's not, some of your wells may end up out of focus. To check the laser focus, click Configure Laser Settings. Here's where you'll set the exposure time for the well bottom, since the laser uses it to focus on. Pick a well, and then choose a site inside that well. Click Preview Pass. You should see 2 peaks on the plot. The first peak should be taller than the second. They should be clearly separated, and the second peak should not be saturated. Now, let's talk about channels and exposure settings. Start by selecting the number of wavelengths you'll be using. If you're using DARPy, set the illumination power to around 30%. That's usually enough. To begin, choose a short exposure time, it'll make offset calculation faster. Set shading correction to auto correction for fluorescence. Then click Calculate Offset. The imager will capture a Z-stack to help find the best focus. Go through the Z-planes and select the best focal plane. Once you're happy with the focus, click OK. If the software can't find a focal plane, just follow the instructions in the pop-up window. Once you press OK, you'll see the new offset value. Click Yes to accept and save it. Then click Test to apply the new offset. Now it's time to set the exposure. Click Auto Exposure, and set the target maximum intensity to 30,000 for DARPy. Repeat this process for all other channels. Just remember, you can increase the illumination power for the other channels, and aim for a target intensity of 50,000. If your exposure time jumps above 1 second, go ahead and increase the illumination power a bit. Under the display section, you can choose to see individual images or overlays during acquisition. Now it's time to run your experiment. Go back to the Run tab and click Acquire Plate. The first well may take a bit longer. After that, things usually speed up. You'll see an estimated time in the status window, showing how long the full acquisition will take. If everything looks good, you can save this protocol to use in the future. Next time you log in, just click Load Protocol and pick your saved version. All you'll need to do is select your wells of interest and verify that the focus and exposure times are still working. Start by checking DARPy. Click Test. If you're not happy with the focus, go ahead and recalculate the focus offset. You only need to do this for the first channel, the other channels will align automatically based on the optics. But do check the exposure time for each channel before moving on. Rename your plate and start acquisition. To stop an acquisition at any point, just press the Escape key. To add a Z-series to your run, click Acquire Z-series under the Acquisition tab. Then, in the Z-series section, set the step size and number of steps. Quick tip: use an odd number of steps. This helps make sure your focal plane will be acquired. Now, for each channel, decide how you want to process the Z-series. If you're making a 2D projection, you can choose options like Best Focus, Maximum Intensity, Minimum Intensity, or Sum. If you only need a single representative image from one channel, you can also choose Single Plane for that one. Go back to the Run tab and click Acquire to start the acquisition of your Z-stack. If you want to save this protocol for reuse, click Save Protocol as before and save it to the database with a new name. Once your experiment is finished, first, eject the plate. Then, close the HCS ImageXpress software and follow the shutdown procedure for the computer and equipment.